But a lot of trig is that way anyway, and if we just draw a picture of what's going on, then, it all falls into place. But you definitely want your calculator out today. We haven't had to do that for a while. I'll give you a minute here to get everything together. And as we talked about yesterday at the end of the lesson, almost always anything that's done as a word problem with trig is going to be in degrees. So probably a good idea to just go ahead and get that mode in degrees right away. And it'll be ready to go. All right, so we've got a whole section here that has solve problems involving right triangles. And again, I'm going to be focusing on the word problems today. And then tomorrow's lesson, it shouldn't be a really long one, looking at what we have for harmonic motion at the end here, but there will be a little video lesson for tomorrow on simple harmonic motion problems. So we're going to start today with problems that should remind you of like basic trig problems you did in geometry. And then things get a little bit more complicated as we work our way through them. And we have to remember, well, some of the properties that we had, some of the theorems that we had back in geometry. First things first, though, we have to know what angle of elevation is. That's the angle through which the eye moves up from horizontal to look at something above, which, yeah, easy way to put it would be if you're going to look at the water tower, normally you'd be looking straight ahead, but at the water tower you'd have to tilt your eyes up. So that's your angle of elevation from the normal horizontal up to the top of the water tower. And then the angle of the depression is just kind of the opposite of that. The angle through which the eye moves down from horizontal to look at something below. So if you want to look at the desk in front of you, you're not going to look straight ahead horizontally. You're going to look down to see that. And that's going to be that angle of depression. So now we think about those two horizontal lines that we have. That is really how we start. Our sight is just straight in front of us. And we have the angle of depression and angle of elevation up there. And hopefully we remember, hey, wait a second. If these are parallel because they're horizontal, won't there be some lines here, some angles formed from these lines? Fancy lines in geometry were called transversals, that would be equal to each other. And hopefully we recognize this angle and this angle would be congruent. Does anybody remember the name of those angles? Got it on? Alternate interior angles. Good. So there was a theorem that you had that said parallel lines imply alternate interior angles are congruent. And that's what we have here. So the angle of depression actually equals the angle of elevation. So that goes back to the whole, we learn geometry to know why we can do the things that we can do in math. What rules tell us that that's going to happen. And in drawings, it's going to be really helpful to start thinking about, which angles are congruent here, what pieces of information do I have that might make this problem easier to do. So we're going to start right off by using an angle of depression, and we have a very nice picture for this one. The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. And it's actually pronounced two ways, and they're both okay. I guess it's okay to pronounce it boy in some parts of the world, so sometimes it just sounds like B-O-Y. But buoy or boy does the same thing. We've got the picture. If we didn't have the picture, what would we have to do? Well, we'd have to think of, a lighthouse over here, and it's 130 feet above the surface of the water, so there's our 130 right there. And then it says that angle of depression from the top of the lighthouse to the buoy down here is 6 degrees. And then we'd find the distance x from the base of the lighthouse to the buoy. Well, here's the lighthouse, here's the buoy, there it is. So this would not be a tough picture to draw, you know, and we could get it all figured out ourselves. Now, I look at this and I think, well, I don't have enough information in that triangle yet to use my right triangle trig. But I've got this little piece of information up here that's 6 degrees. And like we just talked about, I know that these would be parallel lines, and that means that little theta right here would be 6 degrees, and my little degree bubble just got really big, like so. And then I think, well, here's my angle. This would be opposite. This would be adjacent. You think SOHCAHTOA for a second and say, oh, that's tangent. So the tangent of 6 degrees equals opposite 130 over x adjacent. And then we just have to solve it. So whatever we're solving for can never be in the denominator, and the first thing we would do is multiply both sides by x to get it out of there. Or you could put a 1 under the tangent here and think of it as a proportion and cross multiply. Either way, you get the same thing. And then we divide both sides by the tangent of 6 degrees to get x. And I guess the only other thing we need to think about is that we round to 3 decimal places. You know, that's what we do. So once we have it in degrees, which we already talked about, just a matter of punching it in. So we'd need 130 divided by the tangent of 6 degrees. And finish off those parentheses so the calculator knows exactly what we want. And there it is. 1,236.867. Which I hope I wrote down here so I can see it. And the label somewhere up there was all in feet. Now, we might want to convert that into miles, but we already know there's 5,280 feet in a mile, so it's a portion of a mile there. But because it's going to be so small, if we put it into miles, we probably just leave it as is. Alrighty, this one says making indirect measurements, so now we up the game a little bit. You know, there's going to be a little bit more we have to do for this problem. And this says, from the top of the 100-foot tall Altgelt Hall, all right, so there we have our little building, 100 feet, a man observes a car moving towards the building. So here's the first spot he sees, because he said it was moving towards him. If the angle of depression of the car changes from 22 degrees, so this was 22 degrees, and they already put that in here for us because those are parallel lines and alternate interior angles are going to be congruent. And it changes from 22 degrees to 46, so there was the 46, now it's down here. During the period of observation, how far does the car travel? Wow, okay, so what we want to know is x. But to get there, we're going to need a couple of different pieces because we have 2 right triangles here. We have this larger one and the smaller one right here. So we want to see how we can put all of that together. So in the larger one, here's the angle, opposite, adjacent. We would have the tangent of 22 degrees equals 100 over x plus d. We would need that whole side length. X plus d. Well, we'd multiply both sides by x plus d. And then I'd think about what I'm really trying to get at here. And what I really want is x. So I could divide both sides by the tangent of 22 degrees. and just solve this for x by subtracting d from both sides. Like so. So to find x, I still need to know what d is. It's a good thing I have another triangle. You know, that's the only way I'm going to be able to figure that out. So color coding here, I'll go to blue for the other little triangle. And I would have opposite and adjacent again to work with. But this time only one variable. So I'm actually going to be able to figure out what d is. So we'd multiply both sides by d. And then divide both sides by the tangent of 46 degrees. And now I know what d is. Well, Cedar Home, pretty obviously, we could have figured out what d was first, punched it in our calculator, and then put it in there for the red one, you know, so this could all work that way. Yeah, but then there's the danger of a rounding error if you do that. You know, you get into this impulsive, ooh, let me figure out what d is. That's not our answer. That's not the one we want. We want x. And we want it to be exact. We don't want those rounding errors. So now we can substitute that 100 over the tangent of 46 in for d, punch it all in at once, and we won't have a rounding error to worry about. Oops, come on, blue, turn on. All right, so now we just want to be careful and let the calculator know, hey, this is one fraction here, this is one fraction here. Get it all punched in, no rounding errors, should be good. Parentheses. Let me just grab this so I've got it all sitting right here. We've got 100 divided by the tangent of 22 degrees. And we are subtracting, parentheses, 100 divided by the tangent of 46 degrees. And there it is. Again, no rounding errors because we didn't stop halfway and punch something in. So 150.940 to 3 decimal places. I was just double checking that this was in feet. Yep. So I don't have to scroll up and down and look for that label. Oh, I guess I didn't have to scroll up and down. It was right there, way up in the upper corner. So now things started to get a little more complicated here. We had more math that we had to do, but it's some pretty basic algebra with trig. It's not that horrible. So let's see what they give us with this penguin here. So example 3 says we're going to find height above the ground. We've got a large helium-filled penguin, like a Macy's Day Parade penguin here, and it's moored at the beginning of a parade route awaiting the start of the parade. If you've never watched that, moored means tied down, you know, or they have somebody sitting there and they actually hire people to hold those and walk with them through the parade. So that's where it's moored. 2 cables attached to the underside of the penguin make angles of, and here they are right here, 48 and 40 degrees with the ground, and they are in the same plane as the perpendicular line from the penguin to the ground. Really important to us because we want a right triangle in here, and that's what they just told us. Perpendicular to the ground. That's really important. Now, if the cables are attached to the ground 10 feet from each other, well, that's marked on there, good. How high above the ground is the penguin? So I want to keep my eye on the prize here. What I'm really supposed to figure out is the height of the penguin. There's a lot going on in this problem, and I want to remember that's my goal, find an h. But this is very similar to the problem we just did. We have 2 right triangles here going at one time, and with those 2 right triangles, we should be able to put enough information together to figure out what the height is. So, again, it just seems like all our word problems today are using tangent. We've got opposite and adjacent. So the tangent of 40 degrees, the big triangle, will equal h over x plus 10 or 10 plus x. So now I start thinking about what I'm supposed to do here. I'm supposed to find h. So I'm supposed to get rid of x. So it would be kind of nice if this said x equals something, and then when I do my next math, maybe there's something I can put in for x and get rid of it. Because I want all h's when I'm done with this. So I'd multiply both sides by x plus 10. And then divide both sides by the tangent of 40. And then subtract that 10 from both sides. Because remember, my goal is to try to eliminate that x that's in here and just have h's in everything I'm working with so I can find the height. So that sets the stage. Now let's see what we get from that smaller triangle on the inside. Color code that. Well, how's that going to help? That has two variables in it too. Well, again, our goal is just trying to get an equation over there that only has h's in it. So this was a little bit of help. We can solve this for x, and that will give us something to put in for x. So that's what we'll do. We'll multiply both sides by x, and then divide both sides by the tangent of 48 degrees. And like I said, what that allows us to do is now substitute in for that x in the other equation. We're going to put our h over the tangent of 48 degrees right in there. All right, now I'm going to need some more workspace, so I'm just going to rewrite it with a little space. Even more space between those two. Because I started thinking ahead. I don't want to work with fractions all the way through. I absolutely do not want to work with a least common denominator of the tangent of 48 times the tangent of 40. And the way that we solve when we have these rational equations is we multiply the whole thing by the LCD to get rid of all of those fractions. And that is my LCD. So all three of these terms have to be multiplied by both the tangent of 48 degrees and the tangent of 40 degrees in order for us to get rid of all the fractions that are taking place. So that's what I needed some space for. What we do to one side, we have to do to the other, and that means everything on both sides. Now there's a little bit of good news. We do have some canceling here. You know, the tangent of 48. I'm going to cancel out there, and we'll have h tangent of 40 degrees equals tangent of 40 is going to cancel here. H tangent of 48 degrees minus 10 tangent of 48 degrees tangent of 40 degrees. That's better. No fractions. But I want one h. I got an h on both sides. That's not good. I better move one of them over. So I'll subtract h tangent of 48 degrees from both sides. And now it will look like this. Still kind of a monster, and we're not done. Because again, we have to have h by itself. We want h equals and then something perfect that we can punch into the calculator. But that means I have to figure out, how do you get h out of two terms? How do we get h out of these two? Oh, and you got it? Undistribute, yeah, factoring. That's undistributing. Exactly, that's a good way to say it, actually. It's still very ugly, and we still have to divide, because we have to divide both sides by the tangent of 40 degrees minus the tangent of 48 degrees. And let me write what that would actually be as a perfect answer here. So if it said exact answer, we'd actually have to leave it like this. But it's a word problem, and they want to know what it is. So we're going to need a couple of sets of parentheses here to let the calculator know, hey, this is everything in the numerator. This is everything in the denominator that we want to divide by. And yeah, it's going to be kind of messy looking. Start with a fresh page at least. So we had negative 10 tan 48 tan 40 divided by tan 40 minus tan 48. All right, gotta be really careful with all your parentheses in this one, and make sure you finish up, like tangent of 40, stop and put the parentheses on there. Whew, there it is. So 34.323, and labels again. Feet. So another one where if somebody says, well, Cedarholm, couldn't we have figured out what x was first and then plugged it back in? Rounding errors. That's what happens when you do that. You have to figure out, how do I get the variable I want all by itself so that I won't have intermediate steps where I'm punching things in and rounding. And on the tests, I have to take off if you do that, even if your answer comes out right. If I'm looking at your work and I see halfway through that you gave me a decimal for something, I gotta take points off for that. When you get to the AP exam, that's a huge hit in calculus. So make sure that you leave it all perfect till you get to the end. All right, this one. This reminds us that the real world out on the oceans uses bearing versus what we use for our angles. And this has a U.S. Coast Guard patrol boat that leaves Port Cleveland right here at A and averages 35 knots, nautical miles per hour, traveling for 2 hours on a course of 53 degrees. Well, we would have looked at this and said, that's not 53 degrees. What are they talking about? Bearing. Bearing is from due north. So this is the 53 degrees when you're talking about bearing. And so they traveled here for 2 hours. Then they had to change their course. So it says they went on a course of the 53 degrees, then 3 hours on a course of 143 degrees. And we're supposed to tell where this boat landed? Because it says, what is the boat's bearing and distance from Port Cleveland? Whew. Well, I need more info. I don't see anything inside that triangle yet that's going to help me out. So I started thinking, they did tell me how fast it was going, and they did tell me how long it traveled. And this little formula, distance equals rate times time, would help us figure out what our labels should be for the side lengths of that triangle. So the first time around they said it went 35 knots per, nautical miles, knots per, I want to say knots per mile, no, nautical miles per hour, traveling for 2 hours. So the first distance was 35 times 2, 70 nautical miles, knots. I'm going to use NM, so we remember that as nautical miles. Oh, well that's good news, because that gives me a 70 right there. That's one side of the triangle. That's good help. And then 3 hours at 143 degrees. Well, did they say that it changed its speed? No, the good news is they gave us average speed, which means however long they were doing this, they were doing it at 35 knots. So that second distance will be 105 nautical miles. I'm going to put that on here too. Okay, so what do I need? I need to know the bearing and the distance. And they're reminding us here that this would be a 90-degree angle. Well, we could find the distance with the Pythagorean theorem right now. A squared plus b squared equals c squared. Let's do that. $126.194. Those of you that are punching it in, make sure I'm punching it in right too. Get it all down here. 126.194 nautical miles. Now I'm not going to write that on my triangle. Same reason we talked about earlier in this chapter. I might have miffed it. You know, you never know. Big fingers hit something you didn't mean to hit. There it is. But I started thinking about that bearing piece. And I realized bearing is from due north. So I already have this 53. If I could just figure out what this theta is, then I could add that to the 53, and that would give the bearing from due north. Well, it's a right triangle. I can figure out what that is. Opposite and adjacent. I could use inverse tangent on this little bugger. So tangent of theta is 105 over 70. So to get the angle, we're going to need inverse tangent. And then because I don't want a rounding error, I want to make sure that I punch in 53 degrees plus whatever the inverse tangent of 105 over 70 is. I mean, you'd really have to not be paying any attention to get a rounding error on that one, but it could happen, so we can punch it in. Second inverse tangent, 105 over 70, and add the additional 53 degrees. And the bearing is 109.310. degrees. We probably better label that bearing. So bearing and distance. So that one, Again, the picture, incredibly important. If you get an accurate picture, then you can start to see how everything comes together. And that was definitely tougher than what they would have had you do in geometry. In fact, I think you maybe had one bearing problem that you looked at in geometry, if you got to it. So the rest of this is going to be the simple harmonic motion. And like I said, hang on for that until tomorrow. I'll give you some practice at this first. And again, the pictures are incredibly important. We do only have one assignment on this. And today you'd be able to make your way through 19. The simple harmonic motion, I'll go ahead and uncover this. But these, you'll have to wait until you watch the video tomorrow. There it is, some good old-fashioned practice on some trig word problems.